There we go.
Okay.
Go
Sweet.
ahead.
Yeah. So a couple weeks ago, I think it's about a month ago, about 4 weeks ago, I did a presentation on DynamoDB basics. So I wanted to come back and go into some more interesting design patterns. This will be a little more of like of some of the cool things we can do with Dynamo and why it's interesting and why it's powerful. So for a quick refresher on the tools that we have and the things that we need to understand with Dynamo in order to know how we're going to store data with it. Everything that we're going to do is getting and querying by the quote-unquote primary key. That primary key consists of two pieces. It consists of the partition key and the sort key. So the partition key it's more or less where the data is stored, like what partition, where internally how they store it, and when we provide when we do a query, we have to provide the partition key exactly. And then the sort key is how the data in that partition is sorted, and that one we can do more complex queries on. So we can query by giving a partition key and then either not giving a sort key or giving a comparison or a begins with or a range on that sort key. And then we also have the ability to use filters. We tend to try to avoid those when we can because it's going to read everything and then filter. So filter is more useful when your everything that you're reading is a small set. So then you can just filter that down at the end. Basically, don't use filter if it's something that you wouldn't do in memory on your box. So one of the new things we're going to talk about here is global secondary indexes. So one of the kind of simplistic ways to think about a global secondary index is that it acts like having a second primary key on your table. So what you can do is you can specify a new partition key and sort key, and that gives you a second way to query your data. Every record that has those fields on it will be queryable in this global secondary index. So you can exclude something from the global secondary index by not having these fields on that record. As for implementation, it is implemented under the hood as a separate table. So whenever every GSI that we add, we're incurring additional cost, the cost of having another table. Okay, so let's get into some examples. So let's start with some pets. So we're going to say that we're going to store some pets, and the pets have owners, names, a species, like if they're a cat or dog or whatever, an age, and a color. And the access patterns we want to support are we want to get all pets for an owner, and we want to get a specific pet. So in order to do that, we can have a table as you see here where the partition key is the owner's ID and the sort key is the pet's name. That way we can, if we query by only providing the owner ID, then we get all of the owner's pets. If we provide the owner ID and the pet's name, then we get just that pet. So things are going to get a lot more complicated from here, so I want to take a break and see if anyone has any questions before we start getting more complicated.
Can you query just by the sort key?
No, you always have to provide a partition key.
So what is unique?
The combination of the partition key and sort key.
Okay.
Yep.
And when we say entity, it means like there can be multiple other columns.
That's a word I use to help explain that this is a pet. That column will gain more value, more meaning on the additional slides when we have other things that we're storing.
Okay.
I'll just point out, and I know you know this, but like you can scan the whole table for things that match the sort key, but that's
No, you can't.
Oh, okay.
Yeah,
You can, but you will not.
You are capable of doing that. If you're going to do that, come check with someone else who's used Dynamo first to make sure that it's a reasonable use case.
You can until it's time to code review.
Yeah. So
They do offer it and don't give enough warnings about it because it causes all sorts of problems.
okay, so
And now you can leave. No,
so let's say that we've got this table, right, where we've got the owner IDs and the pet's name, but let's say we want to get all the cats. Right? That's the species. We have no way right now, without doing a table scan or something equally weird of finding all the cats. So that's where the global secondary index comes in, because we just found another field that we want to query on, right? That isn't the owner ID or the pet name. So what we might do is we might have our base table that has its owner ID, pet name, and then we might have a GSI where the partition key is, wow, I misspelled species. The partition key is pet species, and then the sort key is the owner ID, right? And that will let us get all of the dogs or all of the dogs for a certain owner. Now, one of the interesting things that you notice here is the base table, the combination of the owner ID and the pet name needs to be unique. For the GSI, it does not need to be unique. So we can have like owner 47 like B2 or something can have multiple dogs, and that's just fine. So we have this working. We've got this table in this GSI where we can get all the dogs or get all of Bob's cats. But we've got this owner ID that we've got in the table. So if we go back, right, that partition key is an owner ID. And so we're going to want to store some information about the owner as well. So how are we going to do that? And now, if we were in SQL, or if we were thinking like SQL, we would have an owners table, right? We've got a pets table, great. Now let's create an owners table, and the owners table will have a partition key of owner ID, and then we can query them both and join them together, right? So that's okay, but like, what if I want to get an owner and all of their pets? Like, I have to query both tables and join, and joins, like, even in SQL, joins aren't cheap. They're fairly expensive, and in Dynamo, that's not a thing that they provide for us. So we would have to query both those and join them in memory, and it like there's a better way. And if we store the owner and the pets in the same table, then we can get them out together with a single query, and don't have to do any joins here. So I'm going to say that let's take our table and let's keep the partition key as the owner ID, and then let's just take the sort key and just call it sort key. Let's keep it generic. And then we're going to end up with something like this. So in this table now, we have our partition key and our sort key. And if we put an owner record in the table, then the partition key is going to be the owner's ID, and the sort key will just be the string literal just owner. So every owner will have the exact same sort key. And if we put a pet in the table, then we'll have the partition key be the owner's ID, and the sort key will be the string literal pet, and then the pet's name. So it'll be a composite field. So what we can do is we can get owner by ID, and the partition key would be for example, it would be 4A7B, and the sort key would be owner. Or we could get all pets for that owner, partition key 4A7B, sort key begins with pet. Or we could get owner 4A7B's pet name Spaz, which was one of my cats when I was a kid. So that would be partition key 4A7B, sort key, exact match on pet Spaz. And I'm using a pound symbol there just as a symbol that I decided on to separate these values for visual representation. Dynamo doesn't care what you use in there. So that works. But what about when a pet dies, right? If a pet's dead, then do we still want to be getting it from the database? What if we want a status field on whether the pet is alive or dead? Well, what I can do is I can add that status into the sort key on the pet. So now, if I want to get all the pets that are alive, I say sort key begins with string literal pet, then alive. Or I can still get a specific pet, I just need to provide its status as well, right? So I say get alive Spaz or get dead Spaz. I'm assuming that I know whether if I'm looking for a specific pet, I'm assuming that I know its status, whether it's alive or dead for this
Can't be sure
model.
if the cat is dead or alive until you check.
Well, that way you can have two cats named Spaz, they just can't be both alive at the same time.
Yeah.
Replace your cat.
Oh, well, actually, we can't die either. Never mind.
Yep. So so this way I give this example to show that This is something that we're doing in payments a couple times where we're using status as the beginning of a sort key because it provides for a little more powerful selection and lets us quickly find things that are matching a criteria with that begins with query, right?
So the hash to separate the different parts here, have you seen that convention anyplace else before?
I don't remember.
I think I like it.
In the
Are we doing that in payments?
Mhm.
Nice.
in the AWS example, whatnot video that you shared with everyone, that's what
Yeah,
he uses
he's using
as
a
well.
hash?
Yeah,
So
that's
right.
there's AWS conf talk that he uses these for.
Cool.
I like it.
Yeah, I've used, I think, double pipe before, and that was fine, but I like hash better. All right.
It just can't be something you use
Yeah.
in the value, right?
Yep.
It cannot, you can't
I mean,
escape it or something.
it's not that it can't, it's that it makes it harder if it is.
Right.
Yeah.
Right.
Yeah, How would it?
Yeah, like that. Okay, it's easier if it's not something that you use in the value is
Yep.
what I
Yeah.
probably should have said.
Yep. All right, so pets need vaccinations, right? And a pet can have multiple vaccinations of different types, even multiple the same type if they're getting multiple doses over time. So we're going to try and model that in here as well. And so we've got a vaccination entity now with partition key again, still owner ID. But then this sort key, we're going to have string literal vaccination, and then the pet's name, and then the vaccine type, and then the date given. And so that lets us do a few different interesting things. I mean, obviously we can get all vaccinations for a pet if we just do begins with vaccination, then the pet's name, like vaccination spaz. But I can get all of Spaz's rabies vaccinations by saying begins with vaccination spaz rabies. And I can even get things over time. So I can say, give me any rabies vaccinations that Spaz has had in the last 2 years by saying partition key 4A7B and sort key is greater than vaccination spaz rabies timestamp for 2 years ago. So,
So is entity actually a column here, or
No, it's
just a concept?
just to help us think about it.
So what if you are looking for all the vaccinations for rabies, irrespective of the name?
Yeah, in that case, that is not supported by these access patterns. So we would need to build an access pattern in for that.
It's not that includes in the.
No, so the sort key is, yeah, you've got begins with and you've got greater than less than. So you have to provide everything in the sort key from left to right. So we could totally build that, but it isn't supported in this
So that
list.
would be a new row, and we'd have 2 ways to access vaccines.
Yeah, or maybe we'd make a GSI on it or something, or yeah.
Are you going to talk about that?
About specifically this one, or
Not specifically that one, but as something like that. Like
I'm gonna have a single table with a GSI. Yeah.
Okay, cool.
Yep.
We should come back to that after he talks about that.
Yeah,
then.
yeah.
I just don't have an immediate answer because I haven't thought that example through yet. All right. So before we get to that, one other thing I wanted to give an example of is everything we've seen so far, right, has that same partition key. I'm putting the partition key for everything so far to be that owner ID. And the question is, like, what if we want to add something that doesn't have that same partition key? Is that okay? So I've got this example of a species record that has general information about a cat. You know, a cat needs these vaccinations. A cat can have these colors, etc. And yeah, we can store that in there too. It's okay that it has a different partition key. We're still saying what it is by having that sort key be the string literal species. So,
As long as it's never. Well, I guess like it would get weird if that species name overlapped with any of the owner IDs.
yeah, if the species name was the same thing as like
Like if the owner ID was their first name and someone was named Cat.
no, that would actually work because you would still specify the sort key has to be string literal species.
I know, that's why I adjusted what
Yeah.
I said. It would be weird.
But
Because
you can still make it
end
work.
up with things like landing in a partition together, and like
You kind of want that actually. You kind of want like things spread across partitions and all mingled together so that you're having distributed access.
I guess like we'll take it up after. Like
Okay.
You're right. Like it would work. I just think it'd be a little weird. It
Okay.
could get weird.
Cool. All right. So this last thing, like that's cool that we added the species, but you know that same question went to back before. Like, what if I want to get that, and then also get all pets that match that. So like get species information and all pets of that species. So give me the vaccination, like the information about about a cat that includes their vaccination schedule that I need to do, and then also give me all the cats. So we're gonna bring our GSI back in for that. And so now we've got this base table where we have the those entities, right? The owner, the pet, the vaccination, and then we got this GSI. Now I moved the species down to the GSI because if we wanted to query species and then the pet by species at the same time, then that would need to be on the GSI as well. So, but it would. So if I was to implement this myself, that species row where partition key is species name and sort key is string literal species, that would probably appear in both the base table and the GSI. I was just preserving space right here. But yeah, so with this setup now, I can query the GSI because I specify if I'm going to query the base table or the GSI. So I say query the GSI where partition key is cat, and that's it. And then I get back information about cats and all the cats. Or I can say I can query where partition key is cat and sort key begins with pet, and then again I still just get back all the just all the cats. So we preserve our previous access patterns. So going back over all those access patterns that we covered with this, so I'm going to jump back. So this table design right here is going to power all of these access patterns. So that's 11 different access patterns with a single table and one GSI. And we've got, I think 4 different types of data being stored in it. So I think that's pretty cool. I think it's pretty awesome to be able to have that all in a single table and to only be paying for that 1 or 2 tables because we have that GSI on it, right? And this, yeah, so I will point out that as a final note for this, before I just open up for more questions, that as we've seen here, this was all relational data, right? There were foreign keys, there were things that were connecting things to each other. So NoSQL does not mean non-relational. It's not the same thing, right? Data is relational or non-relational, and that data can be stored in different systems. So you can store relational or non-relational data in SQL or store it in Dynamo. The databases themselves are not relational or non-relational. So and by putting relational data in Dynamo, we get some cool upsides like the ability to get multiple types of records that are connected together out with a single query. All right, questions? Do you have time for questions? We have a minute.
Yeah, I'm
Okay.
not gonna take 30 minutes. So.
Okay, cool.
So I guess the video you shared with your team, was that the one where he was saying that we should have, if you took it to its logical conclusion, we should have one table for all the data in the world?
I don't think he said that, no. But this...
There's one video I saw at AWS
Yeah.
conference, and when I came away from that, I was like, it sounds like they're saying that we should have one table for everything.
So this was an AWS video. I'm happy to share it if anyone wants to dive deeper into this, because he does go deeper into these patterns, and he gives some more examples and things. I definitely inherited some of this from that video, so...
Cool. Any other questions?
I have a question about querying GSIs.
Yeah.
So the sort key, or the primary key, which is the partition key, and the sort key
Mhm.
in a GSI can be repeated, right?
Does not have to be unique.
So when you're querying, you don't know exactly how many you're going to get back.
Yes, you cannot do get or batch get on a GSI. It's always query.
Cool.
Any other questions?
Can you flip back to your slide with the GSI?
This one?
Yeah. And one thing that I'm not sure on is so you have the base table and you have a GSI.
Mm-hmm.
You're saying that when you insert a pet, it's gonna have a partition key and a sort key for the base table. So you input owner ID, DLee, pet, spaz,
Yep.
and you put that in only one time or two times?
I put it in once.
Okay, and so you have like a partition key field, so you have something that's like,
Yeah.
like partition key base, sort key base.
Yep.
Partition key GSI, sort key GSI.
Yep.
Is that right?
Yeah, sorry I didn't show a full example of a record. I should have done that. But you can everything that I'm focusing on here is just the basic key structure. In Dynamo, since you can stick whatever other information you want on the item, so each of these records, each of these entities, right, is going to have plenty of other fields other than just these two. And so if I take this pet and if I insert a pet, I'm going to expect to insert a pet with a field called partition key, a field called sort key, but then another field like Matt was saying called GSI partition key, and another field called GSI sort key. And then since some of these sort keys are composite fields, he's probably also going to have fields for each piece of that composite, right? He's going to have a status, a pet name, a color, a species, all of that. We configure when we set up the table which of the fields on an item are indexed by the base table and the GSI, and which one, and everything else the table structure doesn't care about.
Since when you create the entity in the base table, and what kind of latency is there in getting it to the GSI, and should I be worried about that?
It is eventually consistent, and in practice, it is fast enough to be production usable. But there is no guarantee of immediate copy over. It is just eventual consistency. It's like sub-millisecond stuff usually. Cool. Thank you, everyone.
Thanks.